Hello, and welcome to this Beyond Clean virtual conference. The speakers for today's conference, the sponsors for today's conference, and the Beyond Clean team are all so excited that you're here. If this is your first time joining us for a Beyond Clean virtual event, I want to call your attention to a couple of event functions. All of the windows on your event screen are movable. You can shrink them, you can enlarge them, you can move them, whatever you need to do to create the event feel that works best for you. In the upper right corner is a resources tool. Download conference sponsor information and the resources and links that your speakers have provided for you. On the bottom left, you will see a Q&A or question and answer tool. Any questions that you have for the speaker during each session can be submitted to them using this feature. Our speakers today will bring you a wealth of knowledge, and all of their information can be found in the speaker bio tool on the right side of your screen. Along the bottom are the icons for each of the windows as well. Clicking these will minimize and maximize each window. This will be an action-packed conference, and there are breaks between each of the sessions. So feel free to grab a snack, check on the dogs or the kids, assemble a tray, do some jumping jacks, whatever you need to do before joining us again.
Right. Good morning, Sterile Processing. My name is Lindsay Brown from Beyond Clean, and I am so excited that you're joining us today. If you've tuned into a virtual event with us before, you know the lay of the land of our event platform, but I do want to call your attention just one more time to a couple of event features. Number one, if you at any point experience any video or audio delays, try a quick screen refresh. I know it's one of those like restart button options, but a quick reset or refresh of your screen can go a long way. I'm excited to welcome you to the second annual Water Quality Conference. Some of you may have tuned in last year to our Pipes to Patients Connecting Water Quality to Sterile Processing Success Conference, where we talked about things like water use to reprocess reusable devices coming from a validation perspective. We talked about dealing with emergent water issues. We talked about collaboration between facilities and sterile processing. And we're going to take those conversations a step further this year and talk about things like, is water quality our responsibility? And when something goes wrong with water, what do we do? We're gonna have some really, really powerful conversations today, some panel discussions, some lecture style presentations, and I'm really, really excited that you're tuned in. I want to give a huge shout out to our event sponsor today, Verda Water Quality Systems, for helping make this day of education possible. And also a thank you to First Case Media for their collaboration for today's nursing credits. The CE credits for this event will be available to you after the event is complete. You'll be automatically transferred to an event survey. I ask you to please take your time filling out that survey, because what we do with that information is we use it to make future events even better, even more powerful, even more meaningful. So please take your time with that survey. Let us know what you want to see in the future, and definitely provide great feedback for the speakers that we have today. I want to call your quick attention to the resource window that's on the right-hand side of your screen. Our sponsor, Verda, has provided brochures, product information, a lot of really great resources for you to take back and share with your department leaders, with your facilities teams, and also certainly follow Verda and Beyond Clean on LinkedIn. You can access those links in that resource window as well. Our first session today, I'm so honored to announce. It's my colleague and friend, Jeffrey Paquet, the CEO of Verda Water Quality Systems at MMIC Medical Systems. Jeffrey's 30-year background in product development and design has led to his incredible expertise and understanding related to solving water quality management issues. He's dedicated, and you'll learn this through this presentation, he is dedicated to providing sterile processing departments with the tools that you need to ensure that you have the highest quality of water for every reprocessing cycle. He is our water quality Beyond Clean expert. So if you want to access some of his water quality educational information, you can visit beyondclean.net and click on Expert Series. His presentation today is Sterile Processing, is water quality our responsibility? And so without further ado, Jeffrey, I'd like to turn this virtual stage over to you.
Thank you very much. Welcome. My name is Jeffrey Paquet, and I serve as the water quality expert for Beyond Clean. In my day job, I'm the CEO of Verta Water Quality Systems and its parent company, MMIC Medical Systems. Like many of you, I've come to understand water as part of an activity where water quality is important, but not the focus of the product and services I am providing. However, I found out that managing water quality was in my best interest if I was going to be successful at my primary job. I think that telling the story about how I and my team found ourselves being intimately involved with water quality and then being recognized as very good at it will help you also understand your own struggles with managing water and what you and your team can do about it. Our goals for our time together today is for you to answer these 4 questions. Why is it important to take control and responsibility of water quality? How is water quality typically managed at healthcare facilities? What are the problems with how water is managed now and how to solve them? And how do we take responsibility for water quality in the sterile processing department? In the telling of this story, we will answer all of these questions. However, let's look at why we're required to worry about water quality in healthcare and how that flows down to the sterile processing department. A few things about my own story first. Most of my career has not been in healthcare or water quality management. In fact, I've only been directly involved in healthcare for the last 6 years. I have a degree in aerospace engineering, and most of my technical career has been in product development in this industry as well as the automotive industry. When you design products and support services for the industries, they must fit in well with very complex and dynamic systems, and you must create the bridge between technology and humans. This is true of both the products, like the space shuttle, and the manufacturing processes and quality systems that are employed to produce the products. They all involve large organizations where people using technology must work in defined processes to deliver a consistent and desirable outcome. So whether it's NASA, Boeing, or a hospital, at a macro level, the problems and challenges are really the same. When things go wrong, it can always be traced back to a process where either the process was ill-conceived by humans or the humans did not follow the process for whatever reason, good or bad. When I was working with Rockwell International, the manufacturer of the space shuttle, we were governed by a process called a quality management system, or QMS. All healthcare delivery systems have a QMS. The requirements of the QMS originates from regulatory sources and industry organizations whose goal is to ensure we deliver healthcare safely with the best possible outcomes for our patients. 2 familiar and important bodies in the United States that shape and police our quality management systems are the Centers for Medicare and Medicaid Services, or CMS, and the Joint Commission. CMS is the U.S.'s form of public health care insurance, and the Joint Commission is a global organization that healthcare organizations use to accredit their healthcare delivery systems, their processes. Both organizations are stakeholders in making sure that our healthcare processes are compliant and producing good outcomes for patients. These processes are governed by our quality management systems, and these organizations will come to our facilities and audit 3 fundamental things. Oh, lost my notes there. That we are following our QMS, put in another way, that we're doing what we say we were doing. Are we compliant, and is our QMS producing good outcomes? Or put another way, are we doing everything right? And when we inevitably discover we are not complying, we effectively implement corrective action. Or put another way, when we discover we have done something wrong, we fix the process that created the problem. At this point, I'm sure you're all wondering when we're going to get to this water thing. Don't worry, we're going to land there shortly. Remember, I'm an aerospace engineer, and I like to start with looking at the problem from way out in space before we get to the particulars. In fact, we're going to talk about water right here. Both the Joint Commission and CMS have both released documents within the last several years that require hospitals to address the link between water used in healthcare facilities and the danger it can poses to patients. Excuse me, I keep losing my notes here. In 2017, the Center for Medicare and Medicaid Services released a policy memorandum that mandated hospitals adopt a water quality management program to examine all sources of water and their potential risks to patients. We will talk about the problems and the risks in a minute. In 2022, the Joint Commission released the Environment of Care document that addressed the same issue and devised a scoring system for hospitals. These documents are very focused on the domestic water used in patient areas of the hospital and the risks they pose to immunocompromised patients. They are concerned with waterborne pathogens like Legionella that can multiply in areas of the plumbing, HVAC systems, and other equipment where water stagnates and then can be aerosolized and inhaled or otherwise infect patients. This primary risk does not really pertain to the work we do in sterile processing, since the water we use will generally not aerosolize and reach places like the burn unit. However, there are a few ways that these documents pertain to what we do with water. Both documents require patient-centered risk assessment on all the uses of water in the facility. The Joint Commission document specifically refers to the Centers for Disease Control and Prevention's Water Infection Control Risk Assessment for Health Care Settings tool. A mouthful, I know. The WICRA, as an example for conducting a water-related risk assessment. You may have heard of these guys in the CDC. They've been in the news some during the pandemic. The basic risk assessment tool looks like this. As you can see, medical instruments that are processed using water are a source of infection control risk. Since most of you work in a department that probably has some title with infection control in it, I don't need to hit you over the head with the fact that CMS and the Joint Commission will concern themselves with how you manage water-related risks. There is a risk that something borne by water used in your department may cause an infection in a patient. There is also another more general aspect of what CMS and the Joint Commission do during audits, where your water quality management practices will be investigated. You will all have documented processes that your department says it follows. These may be the instructions for use that dictate how to use a piece of equipment or how to properly decontaminate a particular instrument. You have documented processes and procedures for how to track your instruments and even for who is trained properly to clean any one instrument. You live in a world of documented processes. Remember what I said earlier about CMS and the Joint Commission. They will look at what you say you are doing and then make you prove it. I have feedback from the many people in sterile processing that question why water quality is their responsibility. The short answer is because you said it was. Your documentation says you follow those guidelines. So if there's any question that it is your responsibility, let's agree to put that to bed now. To summarize, both CMS and the Joint Commission identify the use of water in the process of infection control as a potential risk to patient safety. They require that you quantify those risks on an ongoing basis and have an active way in which you manage and reduce them. Your department says they address these concerns by following industry best practices through the guidelines in AAMI TIR 34 or something similar, and you must demonstrate you are following those guidelines. While we have established a clear link between regulation, accreditation, and the SBD's department responsibility to manage water quality, we have not answered the question of why we should be the ones to do it. We aren't water experts and we aren't facilities people. To answer this question, I'm now going to tell you that story I was discussing earlier of how my team came to be managing SBD water at multiple hospitals across the United States when we never intended to. MMIC Medical Systems operates a fleet of mobile sterile processing units. Hospital lease these from us when they are renovating their departments and don't want to phase construction or outsource their sterile processing work. They also use them when they need temporary temporarily increase their capacity to process instruments, something we are beginning to see a lot of now that healthcare is waking up from the pandemic. There's a backlog of procedures, in case you were unaware of this. If you attended the HSPA conference in San Antonio last year, you would have seen one of our units in the exhibit hall and had a chance to tour it. About 6 years ago, I came to work at MMIC. At the time, we were in the process of mobilizing on 2 very large jobs with multiple trailers on each site. Since the departments were going to be operating from their loading docks in both cases, they had no way to produce deionized water for final rinse. To quickly review what you may already know, deionized water is typically produced for your department using resin bed deionization tanks, also known as DI, or a reverse osmosis process, also known as RO, or some combination of both. RO and DI use different processes to accomplish the same thing, which is to get rid of ionic molecules that will corrode your instruments, cause staining, and can be the source of wet packs in your sterilization process. To look at this from our CMS and the Joint Commission perspective, these problems increase the risk of incomplete decontamination or sterilization, which could result in a surgical site infection. At this time, we did not see ourselves as the people who were responsible for water. We were just asked to provide the equipment. We provided the AMI documentation to the water equipment provider recommended by our customers. In each case, the plumbing between the water equipment and the infection control equipment was to be specified and completed by the plumbers hired by the customer. Not long after becoming operational, each customer's water tests began showing problems with bacteria. In both locations, they were also having issues with wet packs as well. Even though we didn't really see ourselves as responsible for the issue, we did as we were asked to do. However, the customer did see it as our problem to solve since it was our equipment and they were paying us to use it. At this point, we decided it was time to really get educated about water and the AMI TIR 34 guidelines. In the process of learning that and speaking with both the purification equipment providers and the plumbers, it became very clear that this wasn't a technology or knowledge problem. This was an operational problem where no one was taking responsibility for the end product. The plumbers followed the plumbing schematic that we provided, showing where the water was coming from and where it was going. The equipment providers worked with the plumbers to plumb everything from the purification equipment to the infection control equipment. The plumbers, under the direction of the customer, plumbed the equipment the way plumbers usually do, the straightest runs and the easiest way to connect, and the equipment providers watched what they were doing, knew it wasn't a good idea, and said nothing. I want to remind everyone that this was going on in 2 different locations over 2,000 miles apart, simultaneously with completely different people and companies involved. Going back to my experience with large aerospace and automotive companies, in a generic sense, this type of thing plays out all the time. It's an endemic problem with large organization and large products. It happens in healthcare as well. We are not immune. This is because under normal operations, a task that needs to be completed, let's say making a patient better, is fundamentally the responsibility of a process and not any one person's responsibility. Even though the patient may be under the care of one doctor, that doctor is not performing the lab tests, sterilizing the instruments, or administering the medication. It isn't until the patient develops a problem that doctor didn't expect, such as a patient that has developed a surgical site infection, that we realize the doctor is not in control of the patient outcomes. What is in control is a process and not a person. This is what I call a silo approach, where the end product or parts of it are pulled through various departments, the silos, and if everything goes right, you get the desired outcome. In our example, what would now be a healthy patient. When something goes wrong, however, it can be quite difficult to control the final outcome because the owner of the outcome, the doctor, does not have the ability to simply go and identify and fix the problem in another silo. It's not uncommon for problems never to be fixed, and the owner of the outcome just has to make adjustments for it. We call these workarounds. Luckily, caring for patients and the activities that support that process are routine and in most cases not prone to frequent errors. Imagine there's a few of you shaking your head saying, I don't think so. This is because the same types of activities are performed repeatedly. The processes are documented and receive a fair amount of ongoing scrutiny. However, there are several acute problems with water used in the SPD department that make managing it more difficult than managing the care of a patient. The first problem is that it's not a customer-facing problem. It supports a department that is seen as a cost center and therefore not a priority of leadership in finance other than to reduce costs. This is very backward thinking, but that's a topic for another discussion. Since the department's needs are not necessarily a leadership priority or a finance priority, it is not a priority of other departments that are tasked with supporting the water needs of sterile processing. Unlike dialysis water, which is introduced into patients, it is seen as utility. The same water that is used to flush the toilets, just cleaned up a little. However, critical water used for final rinse is very similar in quality to dialysis water and has a similar level of monitoring and managing requirements as dialysis water. A caveat on that statement is that AMI-TIR 34 does not require the same level of purification as dialysis water, but it's basically the same equipment with some material changes, and this equipment has an FDA approval. AMI-TIR 34 is a complex document that is 66 pages long. Many of you may be familiar with this table. Whenever we get asked to comply with AMI-TIR 34, we always get this table as if it's the whole guideline. That table occurs on page 16. There are 15 pages before it and 50 pages after it that are just as important, with tables and activities that nobody seems to be talking about. Other issues are the responsibility for the equipment, ongoing activities for maintenance, and the testing and monitoring for complying with AMI-TIR 34 fall across many hospital silos and even end up the responsibility of third parties like equipment OEMs and plumbers. Also, major renovations in sterile processing departments don't occur often, maybe every 10 to 20 years. A hospital's primary line of business is not construction. If a problem with a process is going to occur, it is most likely going to occur in a process that is not routine for an organization. Since we have had our own problems with installing systems, we have seen the same problems repeated in new or newly renovated departments. These problems become incredibly difficult to fix once the department is finished and the walls are complete and the equipment is in place. In summary, managing water quality in the sterile processing department is not a top healthcare organizational priority. It's complex, and the responsibility for complying with it falls across many departments that don't consider the final outcome their responsibility. We can sum this up as no one has the ball when it comes to managing water quality in the sterile processing department. A lot of people are involved, but no one is in charge, or everyone is in charge. This is what we see consistently across our customer base. Obviously, there are healthcare facilities out there that are doing a good job. I also don't mean to imply that no one cares, because it's clear to us that they do. There is just a fundamental underestimation of the scope of this activity. I also want to remind everyone that we are just like you. We were just trying to do the best job we could when we had these problems, and it was a direct result of underestimating what we were agreeing to do and not realizing that we had to be the experts. I'm also going to express some frustration with some big name water purification companies on all of our behalves. We subcontract to them in many places to help maintain the systems we put in place in our mobile sterile processing facilities. So we deal with them all over the country. The first criticism I have is that they are not proactive. They will sell you equipment that fits your standard budget, your stated budget, and what you ask for, not necessarily what you need. Their equipment will work, but it could be inadequate for the job they know you are trying to do. You can't rely on them to be consultative in their sales process unless you are educated enough to ask very good questions. If you don't ask the right questions, you may end up getting something that doesn't meet your needs. If these companies are also doing your water testing and you're having a problem, they expect you to be the leader in how to fix it. In many cases, because of the way big companies are organized, the people you're working with don't have the background to help you. Time and again, when the customer is having an issue with water in the hospital and the big company is also working for us in a mobile unit, they will come to us and ask us how to solve the problem. One of the issues with these companies is that they specialize in managing water for many industries. In general, healthcare is only a small part of what they do, and sterile processing is even smaller. In our experience, they are not particularly good partners for us in sterile processing. At this point, we're ready to answer the question, why is it important to take control and responsibility for water quality? The answer is because no one else is, and we said we were. At least that has been our experience. When we can take control of water quality management in our customers' departments, either in their hospital or in the mobile units, we have good outcomes. We have a large customer that is a hospital and a very large healthcare network. It was one of the customers we worked with and had issues with. Before we came on board with them, they were in danger of losing their Joint Commission accreditation and were struggling with meeting expectations around procedure throughput in the OR, in part for water problems in their sterile processing department. They recently revealed to us that they now do more procedures than any other hospital in the network and can attribute that to our ability to manage their water issues. We were successful because we assumed complete responsibility for managing water. Let's move on to our next question. How is water quality typically managed at healthcare facilities? The most complete answer is in as many ways as there are facilities. Another correct answer and very valid answer is for your facility may be, we don't know. Everyone listening today will have some variation on that experience that Verda has, but it will also help make our point in the end. Water is fundamentally viewed as a utility. Most facilities receive water from the municipal source. Some of you may have a private source, but most a municipal source. That is, utilities generally are considered part of your physical plant, therefore fall under the responsibility of the facilities department or facilities engineering. They are regularly responsible for plumbing and boilers and other things that consume or produce water. They probably are members or even lead your facility's water quality team and help prepare the facility's water control risk assessment document. We spoke about this earlier as the method by which your facility identifies and manages waterborne risks across the whole organization. They may be responsible for managing the vendors that work on your water, purification equipment, and the laboratories that do the sampling and testing to the AMI TIR 34 guidelines, or they may not, or they may do some of that. The water purification equipment in some places is viewed as infection control equipment. Its operation and management might fall under the purview of the biomed department. We have also seen this shared between facilities and biomed. Sometimes some of it falls to the SPD department itself. We have seen where one department is responsible for commissioning of the department, and then the responsibility is handed over to other functions once a new department is operational. The most important point is that there are often a lot of departments involved that are not directly controlled by the sterile processing department. This is the silo approach and causes the problems that we have discussed earlier, where it's everyone's responsibility and no one's responsibility. It is also important to point out that between facilities, biomed, sterile processing, the laboratory, and the purification equipment contractor, none are usually experts in the application of AMI TIR 34. Not that they couldn't be, but it's either not their priority or, in the case of SPD, not their primary work focus. Water is supposed to show up and be good. The other important aspect of managing water quality in your department is to recognize that it's an ongoing activity. Just because your water was good and your equipment was running fine today doesn't mean it will be that way tomorrow. It's a bit like flying a plane. It's uneventful until something out of the ordinary happens, and then it's not. My colleague, Lynn Sparks, will discuss some case studies in the session after this that will help make this more concrete for you. Besides something going wrong with your equipment, there are many ways that the chemical and other physical properties of water can be changed by forces both outside the building and inside the building that are out of your control and will be unknown to you until you start to develop a problem. These issues have occurred at every site that we have ever maintained and with some level of regular frequency. A quick example is that many municipalities will change the source of their water throughout the year. They don't normally tell anyone. A different source usually will produce water with different properties and may drive the municipality to treat the water in different ways. All of this impacts the performance of your purification equipment, and it is important to note it also affects your utility water used for decontamination at the sinks, washers, and ultrasonics. It can affect how your enzymes and detergents work. It may also affect the health and operation of your infection control equipment and may cause damage to the medical instruments themselves. So all good news, right? In this type of phenomena, that can cause the mystery problem in our departments. Some issues with processing instruments suddenly shows up, and one day you struggle with it and then you struggle with it for weeks or months, and then it goes away. Since things can go wrong at any time, the more departments involved can mean a longer process for identifying the root cause and managing the problem. Sometimes the fix is that you need to add additional treatment steps to the water before its use anywhere in the department, which means the processing sinks as well. If you manage the sterile processing department and you had to resolve the problems at your facility, how many departments and levels of approval would be involved? Would it take a week, a month, or a year to get it fixed? Some of you are probably saying never. Let's now answer the question, how is water quality typically managed at healthcare facilities? The answer is it is the responsibility and the activities associated with water quality management in the sterile processing department is usually spread across several departments. No one person or department understands completely what is required and how to achieve the desired results. This leads to problems that develop with water that are not effectively dealt with, if dealt with at all. That impacts the efficiency of the department, the surgical workflow, and patient health outcomes. If we go back to our water infection control risk assessment tool, that means that sterile processing is unable to identify and manage the risks associated with its infection control risk to patient care. This does not sound particularly good since we are part of the infection control department. Moving on to our next question, what are the problems with how water is managed now and how to solve the problem? I think we have beat to death the problem aspect of this question, and we don't need to spend any more time on that. So how do we solve these problems? At a top level, the answer is to fully implement all aspects of AMI-TIR 34 effectively. Effectively is to mean that something good happens when things go right and corrective action happens when things go wrong. How do we do a better job of that? The first step is to understand that we are measuring against what we are measuring against and see how we do. This means that someone must understand the AMI-TIR 34 document. Most of you are saying, well, this isn't helpful since we don't understand it now. The good news is that it doesn't have to be you. I will make some suggestions about how you can take control of this process, including this piece towards the end. The important part will be for you to manage the roadmap I'm going to discuss. For now, let's not get overwhelmed and have our brains shut down. There's no time for that now. You don't need to be the expert on the document, but you need to have a basic understanding of what's in it. The first part of the document makes the case for why all this water quality stuff is important. Let's assume we're all convinced that it is. The document then goes on to discuss the principles of water treatment, discusses distribution and plumbing, and the relationship between these systems, and then the stages of the disinfection and sterilization processes as they relate to the levels of purity required for water. The document defines two types of water: purity, utility, and critical. Critical is our deionized water. When we can interchangeably refer to this water as DI or RO. It depends on how it's produced. We use this in the final rinses at the sinks, washers, and sometimes the ultrasonics. It is also used to produce clean steam. Most people often refer to this as their AMI water. Well, that is true. It's not comprehensive. All water used in your department that touches instruments is water that must meet AMI TIR 34 guidelines. Most of the water you use in your department falls under the category of utility water, with a capital U because it means something in terms of the purity requirements it must meet. There are many places we go where water the department is using does not meet these utility water requirements. The document then moves to discussing water treatment and best design practices for the integration of the equipment and the plumbing into the SPD. It then discusses the requirements to monitor water quality and the health of the equipment involved in treating and delivering water to you. Each of these sections are supported with detailed annexes that provide specific background. All this information must be taken into account as part of the project to improve your water-related outcomes in the department. Once we understand what we need to do, where do we start? In classic organizational problem solving, we do a gap analysis. What? It's one of those terms the MBA people throw around. I don't have one of those, but I've used this successfully for this problem and other types of problems in the past. A gap analysis compares your current state of actual performance with the desired state or performance. The current state and the actual performance of your water quality management program is what you're doing now. Items that could be identified as your current state might be a survey of the types of water treatment equipment you have now and how it's designed. Likewise, a survey of critical water plumbing and how it's plumbed. Also, what water testing you're doing and to what specifications. Where in the department are you using water and how do you use it? How is the treatment equipment being maintained? What is being checked and how often are they checking it? What documentation do you have for treatment equipment maintenance and for water testing? Where is that stored and how do you find it? Well, this is not a comprehensive list. It's a pretty good. Answering these questions will help you establish what you have and what you are doing. Your desired state and desired performance are outlined and established by AMI TIR 34. When you compare the future to the current, you should be able to answer questions like, does the treatment equipment and plumbing adhere to the current best design practices? You'll be able to identify what's wrong with it based on the survey from the current state. Am I doing all the testing I should be? You may find that you're not. For example, because your current state plumbing doesn't have enough sample ports or your laboratory is not using the correct test. We see this with some frequency in real life. Are we using the correct type of water based on the infection control IFUs of the instrument? Who is maintaining the equipment? Are they checking everything they're supposed to be and with the correct frequency? Many departments don't know that if you're using water softening or anti-scalant, someone is supposed to check the function of this equipment and the status of its consumables daily. If this equipment is in another room or building, it could be malfunctioning or be out of consumables for quite some time before the situation is discovered. Are the water tests and documentation that prove you are monitoring your treatment equipment and maintaining it stored in known location and easy to access? In summary, you need to know if you need plumbing or treatment equipment changes. Are you maintaining those items correctly and with the right frequency? Are you monitoring water quality correctly? And finally, do you have all the documentation you need and is it easy to find? If you don't, I don't want to trivialize that this is a quick and easy thing to do. It will take some time and help from some experts to do it. But the important part is you understand the basic approach. Once you understand what your gap is between where you are and where you're required to be, a scope of work can be developed. The scope of work will identify what has to be done. This leads to an estimate of how much time and money it will take and a budget. Finally, you can just devise a plan that implements the changes that need to occur. As an example of what a future state for your water quality management program might be, we'll take a quick look at how we do it with our customers and how we tie everything together. Amy recommends that you monitor the quality of utility and critical water as well as the health of the equipment at certain intervals. Here you see an excerpt from Amy TIR 34 Table 6 that describes how often some of the important water quality parameters need to be monitored and how you might do that. Some values need to be monitored daily and others monthly or annually. This is an excerpt and not comprehensive. It's just to give you an idea of what the monitoring regime looks like. The table indicates what is being monitored, for instance, bacteria. What type of test is being used? In this case, a heterotrophic plate count or an HPC test. Where the sample or samples will be taken, there are several here and for this test and 3 places downstream in the RO and DI system. Who's responsible for taking the sample? In this example, it's the maintenance personnel, and it dictates the frequency, which is monthly. If we look at the bottom of this table, we see that resistivity, the inverse of conductivity, will be measured using a meter in the same location as the bacteria testing happens, only it will need to be done daily by the maintenance person. Again, this is an example. Amy is not recommending that the maintenance person is the only one that can do it. It can be anyone properly trained to use the meter, a meter that is properly calibrated per its own IFUs. This next table is from Annex B, monitoring water treatment equipment and processes. The table spans pages 46 and 47. What we see here is an excerpt of this table. While it's not uncommon for sterile processing departments to do a decent job of water testing, the equipment and process piece is often not well executed. The water testing is only to confirm that water treatment equipment and processes are working as designed and expected. However, based on your frequency of water testing, you could have something go wrong and not be aware of it for weeks. While some problems can be seen, like staining, high bacteria readings in critical water can't be seen. This could present a problem for items only requiring high-level disinfection or for instruments that are difficult to sterilize due to their design. You have tests to validate processes and results, but they are generally confirming efficacy based on statistics. Statistics does not mean you don't have a problem. It just means there's a high probability you don't have a problem. As you see in Table B1, there are pieces of equipment that require monitoring daily. We generally find that many of these things aren't being done. This goes back to the silo problem where maintenance or a third party might be taking care of servicing the equipment, but neither party understands nor is implementing the Amy TIR 34 guidelines in their entirety. A good check to see if you are out of compliance is to ask the question, is someone checking on the treatment equipment every day? This is usually a small room located near the department. If someone from the department or another department or the equipment service provider is not going into the room daily, checking equipment and writing down values, you are likely not complying with the Amy guidelines. An example of how important this is, we can look at the last line of Table B1 to locate the line items for monitoring ultrafilters. Ultrafilters are the very fine filter that continuously strains out endotoxins from your critical water loop as it circulates around the department and then back to the treatment equipment. As I am sure everyone is aware, endotoxins are the byproducts of the process of destroying certain types of bacteria. They are pyrogenic in humans, cause a fever, and patients undergoing certain procedures like eye surgery are very susceptible to infection by endotoxins. By definition, a sterilization process that destroys gram-negative bacteria creates endotoxins. This is why it's important to have very low bacteria readings in your final rinse water. Bacteria remaining on the instrument and then sterilized will be potentially contaminated with endotoxins. This could potentially cause a surgical site infection. All ultrafilters come with specifications for pressure drop. Since they are naturally restricting the flow of water through the filter, or said otherwise, they hold back the flow, the water on the other side will exit the filter at a lower pressure. This is predictable and will be a certain value provided the filter is intact and relatively clean. As the filter is used, it will get clogged and less water will pass through it. This means the pressure drop will increase. What often happens with these filters is that before the pressure increases very much, they will blow out. This means they get a big hole in them, and all the endotoxins they were holding back now go straight to your instruments. If we go back to table 6, we'll find that endotoxins are not something that are tested for on any regular basis, only if something else happens. If you have a filter blowout, it may not be weeks before you're aware there's a problem. It is typical to have what's called UV filtration, which is a device that critical water in the loop passes through and is subject to ultraviolet radiation. This destroys pathogens, but the byproducts of destroying pathogens can be endotoxins. Without an intact endotoxin filter, they are going straight to your instruments when you perform final rinse. When we do a future plan for the department, we do one that looks like Table B in AMI TIR 34. Here is an example. We categorize monitoring into 2 types, those that need to have daily or hourly monitoring and those that are monthly or greater. Those items that need at least daily monitoring are monitored by sensors in our system. That data is fed back to us and the customer. If there's a problem like our ultrafilter blowout example and the pressure differential drops too low, an alarm will be triggered. That alarm is a text or an email notification to our techs and in some cases the customer. The sensors allow us to collect and store the data in frequent intervals like every second if we want. Every month we summarize that data into reports that the customer can review and show CMS and the Joint Commission. In this way, our customers can demonstrate that they are meeting these daily monitoring requirements in the guideline. In the table, we can see that we are monitoring the inlet and outlet pressure of the water coming into the ultrafilter. We sample the data every few seconds and it allows us to compute a pressure differential across the filter. If the value drops below the minimum for an intact filter, the system will trigger an alarm and send everyone a text or email. The customer can access real-time data and look at trends over a defined time period from screens in their work area. Our sensors also record all the values, and we use that data to compile monthly reports with trending averages and specification limits that clearly demonstrate to anyone looking at the report that the customer complies. For report purposes, we summarize the data into daily averages, noting that alarms are triggered on any one data point on any 1 second. You don't have to do it this way, but the principles are the same. Daily, someone needs to go into the equipment room, read those values from the gauges, and record the values. That data needs to be accessible for an audit that will occur sometime in the future. For intervals of a month or more, we have a more manual process like most departments are accustomed to. This table shows an example of pH and chlorides, chemical values that need to be tested monthly. In both of these cases, we go into the department, take samples, and then test them immediately with a handheld device. This is important for pH of critical water. The carbon dioxide and air reacts with critical water, and within a very short period of time will change the pH of the sample. If we send this to a lab who might not test it for days, the reading would be inaccurate. For other chemical analysis that can wait, and can't be tested on site, we will send those values to a laboratory. Then every month, the information is summarized in a report that is provided to the customer so they can demonstrate compliance. So if we look at the water quality management plan from the top level, this is what it looks like. The equipment is sending real-time data. Some of the data is fed back to the user and our technicians that access it on smart devices or browsers. Alarms are triggered if something is trending or has gone out of specification so that our technicians can take action. Monthly, we go into the department and take water samples that are either tested on-site or sent to the lab. Monthly, all the data we collect, we collected and testing we have done are summarized in reports that demonstrates the customer is complying with AMI TIR 34. Again, this can be done in a completely manual process. It just requires more people work. To review what you need to know to have a successful water quality management plan in place, you must do these things. Identify all the things that need to be monitored, which will be water chemistry values and equipment health characteristics. Identify the physical locations of where you will be taking samples or where to read equipment-related values. Identify the frequency of monitoring for each. Specify the methods for how the value will be measured. This might be a water sample sent to a lab or reading pressure gauges and recording values. Specify how you want the data to be summarized. Specify how you want the data summarized into reports. Specify where the reports are to be stored. Assign a responsible party to ensure that the monitoring is occurring, that reports are coming back, and if something is out of compliance, it is being taken care of. There is no getting around that this is a lot of work to put in place and to keep up with an ongoing basis. You will certainly require some expertise from other departments and probably from outside resources. It will take time. I imagine a lot of facilities are concerned about compliance, particularly in light of the AMI TIR 34 guidelines transforming into ST 108, a specification. That means that currently you should be doing something. In the future, you shall be doing something. What does this mean for compliance and for accreditation in the short term? What will be at issue to auditors is having compliance problems and no documented evidence that you are addressing the issue. If you have completed this gap analysis process, or you are at least in the middle of it, you can demonstrate that your quality management system can identify an issue and implement corrective actions. You're doing something. If the assessment indicates a condition that may affect patient safety, you will need to implement some type of temporary corrective action. As an example, if you haven't been testing with correct frequency for bacteria in your critical water plumbing, you do it and discover you're out of specification. An immediate corrective action could be to stop using critical water by changing the cycle and the relevant pieces of equipment to eliminate a final rinse with this type of water. At the processing sinks, you could use bagged or bottled sterile water. You might have to increase your level of inspection of the instruments after decontamination, and you might experience a higher level of rejection because of the corrective action, but it will address the immediate problem of using contaminated water to process instruments. Your first step might be to do something small, identify what documentation you should have and to where it should be, then put it there. If you're missing pieces, document a plan for filling in the gaps and then do the work. To review where we are answering a total of 4 questions in this presentation, and we're about to answer the last part of the third question. We are doing a really good job. The first question is, what are the problems and how water is managed and how to solve them? How do we solve them? We do a gap analysis using the AMI TIR 34 specification as our future state. Perform a survey on our department and monitoring activities to determine our current state, and then we identify the gap. We will then create a scope of work that will lead us to cost and timing. We will then devise a plan that implements how the scope of work is executed, in what time frame, and what money and resources will be needed. We will then devise an implementation plan that is how we will do it. That sounds all very nice, but you're not going to be able to do this with help from others in your organization. You will need help from that part of your organization that manages projects, probably construction projects. Your scope of work may involve plumbing changes and require new equipment. Quotes from the equipment vendors and the trades contractors will need to be compiled based on the scope of work developed through your gap analysis. For instance, you may have identified that your current water purification system is inadequate and needs to be modified or replaced. The construction people can then develop a scope of work and costs by working with the vendors and your capital and purchasing people. Once that is done, you will need to convince the finance people that it's necessary and give them a number of what it will cost to remedy the issue. The way you're going to speak with the finance people is that you're going to throw the term return on investment, or ROI, around like it's a football during the Super Bowl. What is return on investment? Simply put, ROI is a simple way of determining if something is worth doing. In general, investment is worth making if its monetary benefit over time exceeds its costs. One way of having this conversation is to quantify the relationship between the cost of your implementation plan to revenue produced by surgeries and procedures. Complying with AAMI TIR 34 will improve the volume and quality of your work product. This means you will be able to increase your hospital's ability to do surgeries and procedures. Your finance people should know exactly how much your surgical activities generate revenue per hour. If your department does more work with less defects, it should increase the number of hours of surgeries per month the hospital can do. It may only take an improvement of 10 or 20 hours in the first year to pay for a project. Then every year after that, the more money the hospital is making without any cost. Another question you can ask them is, how many surgical site infections does it take to pay for the improvements? Other things they should consider are the efficiency increases, the reduces the pressure on overtime in your department and other departments, and the need for additional employees. Instruments won't need to be sent out for repairs as often. That means less activity around quality control and the work it takes to manage the inventory in and out of the department. Finally, the golden hammer: what if they shut the department down and we have to outsource everything for months? The bottom line is that having compliant water saves the hospital money and increases its ability to generate revenue without adding ORs or more employees. Finally, we're coming to the end. Question 4 is, how do we take responsibility for water quality in the sterile processing department? Well, we have really answered most of that already. One is we advocate that a knowledgeable party who understands the AAMI TIR 34 guidelines and what is coming in ST 108 assist you with doing a gap analysis. Involve the necessary people in your organization so that a scope of work can be developed and planned to implement the changes with costing. Secure the funding from finance using the return on investment discussions. Once the improvements are in place and the monitoring is happening, take responsibility to make sure that all activities are always happening, that you are getting the necessary documentation for compliance, and when something is not right, that corrective action is identified and being implemented. I think that brings us to the end of our discussion on the operational aspects of water quality management. I'm Jeffrey Paquet, CEO of Verta Water Quality Systems. Thank you for choosing to spend your valuable time with me.
All right, Jeffrey, thank you so much for this incredibly detailed presentation to get us kicked off today at this water quality conference. There's a lot of great information in this presentation. If anyone wants to access these slides and use them to reference, you can certainly download those from the downloadable resources tool. I do want to encourage everyone, if you do have questions for any of our speakers throughout the day, please feel free to send those in. On the lower left-hand side of your screen is a Q&A function. You can enter any of your questions. We'll keep them completely confidential. So chances are, if you have questions, someone else probably has a similar one. So I encourage you throughout the day today, ask those questions. They can be simple, they can be complex. We have such a great lineup of subject matter experts on this topic of water quality today. So I would encourage you all to take advantage of them all. As I mentioned before, downloadable resources are available on your screen. Jeffrey, again, thank you so much for getting us kicked off today with such a detailed presentation about whose responsibility it is for water quality. I think you've likely got the wheels turning for everyone who's tuned in this morning, and we're gonna build on that throughout the day. I want to let everyone know that we do have a 10-minute break between each of the sessions. It's a little bit shorter than our typical break, but we want to get to the action sooner rather than later. So we shortened the breaks to 10 minutes. In between sessions, there's no need for you to change anything on your screen. You can simply just keep your browser open and your browser will transition you to the next presentation. So you don't have to do anything at all. If you do need to use the restroom, grab a snack, start the sterilizer, assemble a tray, I encourage you to do so, and then certainly tune back in for our next session. Our next session will be a case study about water quality issues. So I think it'll be a great way to continue this conversation, Jeffrey, that you laid the groundwork for so eloquently. We thank everyone for tuning in today. Thanks for joining us for this early session today. I know I see some West Coast folks on here, so good on you for waking up early and tuning in. I will be transitioning you to the next session here shortly. If you do have any questions for our speakers, like I said, feel free to include those in the Q&A tool on the lower left-hand side of your page. Thank you so much for Verda for sponsoring this educational event. We're excited to have these conversations and to really set departments up for success when it comes to water quality. Thanks everyone for tuning in. Don't go anywhere. We'll be back with the next session shortly.